It's amazing, isn't it? We pop a pill and feel better, but how often do we really stop and think about where these powerful medicines come from?
Yeah, it's easy to take it for granted.
Today we're going deep into the world of specialized metabolites, these little chemical wonders from nature that has a huge impact on medicine.
That's right, a deep dive into the world of secondary metabolites. They're these fascinating organic compounds produced by plants, fungi, and even bacteria.
Our goal today is to understand just what these secondary metabolites are, where they come from, and why they matter so much, particularly for drug discovery. We've got some great introductory material to guide us along the way. So first things first, what exactly are secondary metabolites?
They are, at their core, organic compounds, chemicals produced by living organisms. What's really interesting about them is that, unlike primary metabolites, those essential building blocks like sugars and fats that every organism needs to survive, secondary metabolites aren't strictly necessary for an organism to live.
So they're not the bare essentials. What do they do then? How can we kind of picture that?
You can think of primary metabolites as those basic needs, right? Food, water, shelter, things you can't live without. Secondary metabolites are more like specialized tools. They give the organism an advantage in a specific environment. Like maybe it's a unique scent to attract pollinators or a toxin to deter predators. Secondary metabolites let organisms fine-tune their survival strategies through really specific interactions within their ecosystems.
So this isn't like a brand new field of study, right? People have probably been using these compounds for ages without even realizing it.
Oh, absolutely. The history of secondary metabolites is fascinating. Think about traditional medicine, for example. Many ancient remedies were based on plants and fungi that we now know contain these powerful secondary metabolites.
Makes sense.
Like willow bark. People have used it for pain relief for centuries. And it turns out that willow bark contains salicylic acid, a secondary metabolite, which is a precursor to aspirin. Nature's been our pharmacy for a long, long time.
So we've got a handle on what these secondary metabolites are, but how do they really differ from those essential primary metabolites we talked about? What sets them apart?
The key differences are necessity and specificity. Primary metabolites are universal and absolutely vital for life. Every organism needs them to function. Secondary metabolites, on the other hand, are often unique to specific species or even specific conditions, and they play those very specialized roles we were talking about earlier. They're not directly involved in those core processes like growth or reproduction in the same way primary metabolites are.
They're like specialists, not generalists.
Exactly.
So these specialized compounds are out there doing all these very specific jobs in the natural world. What are some examples of what they actually do?
Well, they have this amazing range of functions. For one, they can act as defense mechanisms, protecting the organism from things like predators or infections. They can also act as signaling molecules, allowing organisms to communicate with each other. And they can even be used in competition between organisms, like how some fungi produce compounds that inhibit the growth of bacteria.
Can you give me a quick example of that in action, one that kind of grabs your attention?
Sure. Imagine a brightly colored flower that gives off a specific scent. That scent, often a secondary metabolite, acts as a signal to attract particular pollinators, helping to ensure the plant can reproduce.
Ah, so it's like a targeted advertisement in the language of smells. That's cool.
Yeah.
Now let's bring this back to something that directly affects us humans. Our source material emphasizes how important secondary metabolites are to the pharmaceutical industry.
Right, and this is where it gets really relevant for us. A significant portion of the drugs we use today are either directly derived from secondary metabolites or inspired by their unique chemical structures. Think about penicillin. It was a revolutionary antibiotic, and it came from a fungus, a classic example of a secondary metabolite that had a profound impact on medicine. Because these compounds have been honed by evolution for specific biological activities, they're incredibly valuable starting points for developing new treatments for all sorts of diseases.
So from a tiny fungus protecting itself to a life-saving antibiotic, that's amazing. As we start wrapping up, what are the key takeaways about these fascinating secondary metabolites?
I think the important things to remember are that secondary metabolites are these specialized organic compounds that play critical roles in how organisms interact with their environment.
Right.
And, maybe even more importantly for us, they represent an essential and constantly evolving resource for the pharmaceutical industry, forming the basis for many of our most important medicines.
It really makes you wonder, doesn't it? Considering how vital these compounds are to the balance of nature, what other amazing applications might we discover in the future by studying these natural chemical powerhouses? Food for thought. Thanks for joining us for this deep dive.
You're welcome. It was a pleasure.
It was great.